Welcome to a video on the hyperboloid of two sheets. As we've seen from the previous videos, the degree and sign of the degree 2 terms, as well as which terms are present, help us determine which of the 6 basic quadric surfaces is given by an equation. To graph a quadric surface, it's often helpful to graph the xy, xz, and yz traces, and these are where the surface would intersect these three planes. To determine the xy trace, we'll set z to 0. To determine the xz trace, we'll set y to 0. And to determine the yz trace, we'll set x equal to 0. Here's the form of an equation that represents a hyperboloid of two sheets. Notice that all three degree 2 terms are present. However, when the equation is equal to positive 1, two of the terms will be negative and one will be positive. Remember, when we had a hyperboloid of one sheet, only one of the terms was negative. So if it fits this form where one is negative, it's a hyperboloid of one sheet. If two of the terms are negative, it's a hyperboloid of two sheets. Two of the traces will be hyperbolas, and one trace will be an ellipse that, if it's centered at the origin, will appear in a plane parallel to the xy plane. And then lastly, the axis will be parallel to the positive variable term. Here the axis is parallel to the z-axis, and notice the z term is positive. Let's go ahead and take a look at our example. We'll start by finding the xy trace, so we'll set z equal to 0. So we'll have x squared over 16 minus y squared over 9 equals positive 1. This is a hyperbola, and because the x term is positive, this hyperbola will open left and right along the x-axis. It's also centered at the origin, so we know that a squared is equal to 16, so a is equal to 4. So we're going to plot 2 points, one 4 units to the right and one 4 units to the left. Since b squared is equal to 9, b is equal to 3, we'll plot a point 3 units up and 3 units down. These 4 points allow us to construct a rectangle that will aid us in graphing the hyperbola. Remember, the diagonals of the rectangle will be the asymptotes. Let's go ahead and sketch those. And again, because we know this hyperbola opens left and right, it would look something like this, approaching the asymptotes from the vertices. Now let's take a look at the xz trace. To find this trace, we'll set y equal to 0. So now we'll have x squared over 16 minus z squared over 4 equals 1. So we have another hyperbola, which is what we expect, 2 hyperbolas and 1 ellipse. Since the x term is positive, it will open left and right along the x-axis again. And since a squared is equal to 16, a is 4. So we'll plot a point 4 units to the right, 4 units to the left. Again, it's centered at the origin. And c squared is equal to 4, so c is 2. So we'll go up 2 units to make a point and down 2 units to make a point. This will give us our rectangle as before. Then the diagonals. And now we can sketch a nice hyperbola from the vertices approaching the asymptotes, here and here. Now this last trace is going to be a little more interesting. If we let x equal to 0 to find the yz trace, we're going to have negative y squared over 9 minus z squared over 4 equals positive 1. And there's no solution to this because both of these terms are going to be negative, therefore it will never be positive. So that tells us there is no yz trace. So now we're stuck with a little bit of a dilemma. We do want to have some form of a trace. We know there should be an elliptical trace. It just won't occur in the yz plane, but it will occur in a plane that's parallel to this plane. What I mean by that is, if this was equal to negative 1, we would be okay because then we could multiply everything by negative 1, and then we would graph an ellipse as we normally would expect. So going back up here where we let x equal 0, if we could find a value of x that would make this equal to positive 2, then if we subtracted it on both sides, that would give us a negative 1 over here. So if we want this to be a positive 2, we could let x equal positive or negative square root 32. Because if we square square root of 32, it's going to give us 32. 32 divided by 16 would give us 2. So that's what we're going to do. Let's go ahead and clear this information off. And it's going to take a little bit more work, so let's go ahead and start it over here. We're going to let x equal the square root of 32. If we do that, it's going to give us 2 minus y squared over 9 minus z squared over 4 equals positive 1. So now if we were to move these terms to the right, they would be positive, and if we subtract 1 on both sides, we'd have a positive 1 on the left. So what we're going to use for our trace is going to be 1 equals y squared over 9 plus z squared over 4. And again, we subtracted the 1 to the other side. That's why this was positive 1 on the left. So now this really isn't the yz trace, it's the x equals square root 32 trace. And the square root of 32, well, square root of 36 would be 6. So this is somewhere between x equals 5 and x equals 6. But this will be parallel to the yz plane, so let's go ahead and use this as our trace. Again, we should now recognize this as an ellipse. The major axis will be along the y-axis, so we'll call this the y-axis and this the z-axis. So since b squared is equal to 9, b is 3, so we'll make a point here and a point here, the endpoints of the major axis. And since c squared is equal to 4, c is 2, so we'll make a point up and down 2 units. And here is our elliptical trace. Again, this is not the yz trace, it's the x equals square root 32 trace. But it does tell us if we take a look at just the yz plane, we should see an elliptical trace. If we put all these traces together, it will produce a hyperboloid of 2 sheets. And here it is. Let's go and take a look at this so we can rotate it. If we take a look at just the xy plane, looking down on it, it would look like this. And you can see the hyperbolic trace here and here. If we now look at the xz trace, you can see the hyperbolic trace here and here. And then lastly, the one that we had some difficulty with, looking at the yz trace, you can see the elliptical traces from planes that are parallel to the yz plane. This is the hyperboloid of 2 sheets. Okay, that's going to do it for this video. I hope you found this helpful. Thank you for watching.